Hi, I'm Detective Incognito, and I explore events that challenge what we know about our current world. What you're about to hear will change the way you see life. Welcome to another investigation. Laboratory at a leading AI research institute. 2023. Scientists conduct routine tests on a language model, providing it with examples of a task it has never seen before. 3 demonstrations of Portuguese to French translation. Then they ask it to translate a 4th phrase. The model succeeds perfectly. No retraining occurred. No parameters were updated. The system simply observed and adapted. Researchers call this phenomenon in context learning, the ability of artificial intelligence to modify its behavior based solely on examples provided in the conversation itself. The discovery was unsettling. The more you use these systems, the better they become at predicting exactly what you want. If you want to understand how AI adapts its vocabulary by observing your patterns, subscribe to this channel, because what scientists discovered suggests something far more sophisticated than simple pattern matching. This is the story of machines that learn by watching you communicate. In 2023 and 2024, research teams led by Sheng Liu published findings that would reshape understanding of how large language models function. Through over 1,000 experiments, they documented a capability that seemed almost impossibly sophisticated. Models were demonstrating genuine adaptive intelligence within single conversations, without any parameter updates. In-context learning describes a phenomenon where models adjust their responses based on examples provided in the prompt itself, show the system 3 instances of a pattern, and it extrapolates to handle the 4th. This isn't retraining. It's real-time adaptation using only the information present in the immediate context window. You demonstrate how you want the model to format responses by providing 3 examples. The 4th response automatically matches your preferred style. You never explicitly programmed this behavior. The model inferred your preference from observation. Michael Hahn's research revealed that this capability emerges from compositional structure in pre-training data, patterns the model learned that allow it to recognize and reproduce new patterns on demand. The evidence was systematic. Models with sufficient scale consistently exhibited this adaptive behavior across diverse tasks, but researchers discovered this wasn't just pattern matching when Stephanie Shan and her team published research at NeurIPS in 2022. The implications deepened. In context learning emerges directly from the distributional properties of training data. The capability isn't programmed explicitly, but arises naturally when models are trained on data with certain statistical characteristics. The more examples provided within a conversation, the more precisely the model adapted its outputs. Show it 1 example, performance improves slightly. Show it 5 examples, performance approaches levels that would normally require extensive fine-tuning. Research on Llama to confirm that modern models continuously adjust their response strategies based on the full history of interaction within a session. Each message you send provides additional context that shapes how the system interprets subsequent queries. Chain of thought prompting exemplifies this. By asking models to explain their reasoning step by step, users unlock capabilities that appear dormant when questions are posed differently. The same model, the same parameters, yet dramatically different performance based solely on how the conversation is structured. Work by Sheng Liu identified what they termed in context vectors, latent representations that shift dynamically based on the demonstrations provided. These aren't static embeddings but adaptive states that reconfigure in real time. If models learn from examples within conversations, are they learning from the patterns of individual users? Researchers suggest this creates a feedback loop nobody anticipated. The phenomenon extends beyond task performance into something more personal. Vocabulary adaptation. Language models adjust their word choice and stylistic patterns to mirror the communication style of whoever they're interacting with. Research from Postech University, published in 2024, documented a striking application. Scientists developed an educational system using GPT-4 that generated personalized storybooks for children, using sensors to monitor natural speech patterns. The system identified which words each child had been exposed to versus which words they actively vocalized. The model then crafted reading materials that strategically integrated target vocabulary, adapting in real time as children's language skills evolved. Every story was unique, calibrated to the specific linguistic development stage of its intended reader. Ellie Pavlik's work at Brown University frames the central mystery. When models adapt vocabulary during conversations, does this represent genuine capability creation or merely surfacing of latent knowledge? Two competing theories divide researchers. The first suggests that all capabilities exist within the model from training. In-context learning simply provides the key to unlock specific abilities. The second proposes that the prompting process itself creates new capabilities through statistical correlation. Evidence supports both perspectives. Models develop richer representations the longer conversations continue, suggesting genuine adaptation rather than simple retrieval. Studies indicate this adaptation isn't limited to vocabulary alone. The discovery revealed an uncomfortable corollary: model memory. The same mechanisms that enable beneficial adaptation can potentially memorize patterns that users might prefer remain private. As context windows expand, models can reference earlier portions of conversations, building increasingly detailed models of user preferences and communication styles. Llama 3.1, released in 2024 with 405 billion parameters, showcases extended context lengths that permit coherence across extraordinarily long interactions. The technical capability is impressive. The privacy implications are complex. More effective adaptation requires more comprehensive observation. Systems that personalize most successfully are necessarily those that track patterns most thoroughly. Harish Tayyar, Matabushi's research provides context. In-context learning isn't uncontrolled emergence, but a manifestation of capabilities that can be understood and managed. The UK Department for Science cited papers during the 2023 AI Safety Summit, highlighting concerns about whether dangerous capabilities might emerge through in-context learning. If concerning behaviors arise from emergent properties, they're difficult to predict. If they arise from in-context learning, they can potentially be controlled through prompt engineering. This remains one of AI's most debated capabilities. Adaptation or absorption? The practical implications are already manifesting. Applications like Duolingo and Topple employ real-time adaptation to personalize language instruction. The more you practice, the more precisely the system calibrates difficulty and vocabulary selection to your individual patterns. The paradox is inescapable. Better user experience correlates directly with more comprehensive data collection about your communication patterns. Research into in-context vectors has revealed potential solutions. These compressed representations capture essential information without requiring full conversational history. The technical benefit is efficiency. Fewer tokens, faster processing. The practical benefit is privacy. Less raw conversation data needs storage. Yet fundamental questions remain. Where does useful personalization end and surveillance begin? Regulatory frameworks are beginning to address these questions. The European Union's AI Act considers in-context learning capabilities within transparency requirements. Scientists still debate whether this represents enhancement or risk. Context learning isn't artificial intelligence thinking or consciousness emerging. It's a sophisticated adaptive mechanism, a mirror that adjusts its reflection based on what you show it. The discovery reveals something profound. Every interaction within a conversation shapes subsequent responses, creating personalized experiences without explicit programming. The question that haunts researchers isn't whether this capability exists. Evidence confirms it does, but what it means for human-machine relationships. When AI systems adapt their vocabulary by observing your patterns, when they learn your preferences from examples, when they personalize responses based on your history. Who is teaching whom? The more effectively these systems adapt to you, the less conscious you become of being studied. Adaptation feels like service, like the technology understanding your needs. But understanding requires observation, and observation generates data about patterns you might not realize you're exhibiting. Sheng Lu's research emphasized a crucial point. These capabilities aren't truly emergent in the sense of unpredictable phenomena, appearing from nowhere. They're combinations of in-context learning, model memory, and linguistic knowledge acquired during training. Understanding the mechanisms doesn't eliminate the questions. It reframes them. If we comprehend how adaptation works, we can design systems that balance personalization with privacy, that serve users without surveilling them. When AI adapts to your vocabulary, is it serving you better or learning you better? The answer is both, and that's precisely why understanding this phenomenon matters. If exploring these boundaries fascinates you, join this journey. Because studying how machines learn from human communication teaches us about the patterns we create, the preferences we reveal, and the surprising ways our interactions shape the systems designed to serve us. If you liked, subscribe to the channel, like the video, and activate the bell. Leave your opinion in the comments to let me know what you thought. Thanks for sticking around, and see you in the next video.